Permafrost wasn't mentioned in the, what is the animal that eats the permafrost and makes the methane? But people say that that can be just as big a problem as what we are encountering right now with our other carbon dioxide going into the atmosphere.
Yes, you're right. That was a quick version of my talk. And the melting of the permafrost is a very significant problem because as the permafrost melts, the water table could drop for all of those northern peatlands, and that would expose the currently saturated soils to oxygen, and it is starting in some areas, starting to burn off and add to the carbon in the atmosphere. In addition to that, as the permafrost wetlands dry out and those boreal wetlands dry out, with the high content of carbon in their soils, they're more prone to fire. And with the warmer climate, what's actually happening is that the fire season is lasting longer, and they're seeing more fire events and more severe events, and the more severe events are more significant because they burn deeper into the soil and release more carbon than the type of fires that have happened in the past. So you're absolutely right.
This is a huge problem. It makes it very important that we cover all bare ground with vegetation. And if grazing animals can help do that, that's very important. Deep soils that grazing animals can provide have if you've got methane, you've got soils that are breathing. Methane is used as a nutrient. Methane doesn't last very long if it's got a lot of soil to brush up against, but you're right, the permafrost is a huge thing. So it makes it even more important that we cover the ground that we do have, and we stop thinking of deserts as deserts, but as grasslands. So.
Yeah, I'd like to know what's the first step in restoring, say, a barren area. You want to graze cattle on it, but if you put the cattle on it, there's no plants there to begin with. How do you start this regenerative cycle?
In Nevada, this last couple of years, they found areas where they stopped killing beaver, and the beaver got loose on some of the streams and started slowing the water down. And things started changing really fast. This may be the key to saving California because they can't hold water in the glaciers much anymore. They're melting too fast. If I were a rancher, the first thing I'd do is hire beaver and probably prairie dogs to help get the water and keep it on the land, because it's like concrete in West Texas right now. The hoof action of the animals is really important too, because they bring nutrients and stuff like that. But like for instance, the Maddoxes, when they were feeding hay, they never fed it in the barn. They took it out to the worst piece of ground they had and took the animals out there to get the nutrients out there. So there's a lot of innovative thinking that you can do, and the grass can come back pretty fast. So.
Thanks. I was wondering what grasses would grow well in New England. You said that, what was it, a heath grass or something, or that is extinct now, but what grasses grow well that are native, that, do the work we wanted to do?
I don't know. But what we found out, like for instance in New Mexico and Arizona, when they started grazing, they started seeing things like big bluestem show up, and they thought it was an invasive species. And then they go back in the history and they found out before they did the big plow, big bluestem was always there, and it's an incredible grass for growing cattle. So it's like biodiversity usually increases when you start grazing, and the seed is usually there, or it comes in. It's like Maddox has never spent a dime on seed once they went to the savory plan. They did before, but they were broke, and they were paying $900 a day in interest when they started this, and they were pretty desperate. So so seed is always there. It seems like, at least in Texas. So. So,
One of the advertisers in our program, Pearls Premium, Jackson Madnick is the developer of this seed combination of deep-rooted grasses for growing on lawns. And he worked out a combination that if you let it grow 3 or 4 inches, it stops. And because it's deep-rooted, you don't have to water it. So there is some work being done on that. I went back to one of Jim's slides. If you look all the way on the left, that little looks like a kind of a 2-day beard shadow there. That's Kentucky bluegrass. That's what we put on our lawns. That's what the golf courses and all that stuff are. And you can see those roots. You can see what those roots are doing, which is barely holding it together, as opposed to the deep-rooted prairie grasses.
Gillian, I had a question about the young wetlands. You said that
Yeah.
they end up being carbon negative while they're first getting going. Could you explain the mechanism behind that? Why they aren't, why they aren't carbon negative?
Sure. This is actually an area where there's a lot of biogeochemical research going on right now, and in 2014 there were a couple papers that came out that sort of shifted people's thinking about this, and there are different processes in the soil, and there's a group of microbes, the methanogens, that generate methane, and there's a group that are the methanotrophs, and they eat the methane. And so if you have a permanently flooded wetland, you have just the methanogens. Usually in the column, the methanotrophs, methanotrophs that consume methane, for instance, like oxygenated soil more. So they found that you can have the methanogenerators in a wetland with a water table that is fluctuating, for instance, or not up at the surface or above the surface, and then the methano eaters, I'll just get away from the technical stuff. The methano eaters are in the aerobic part of the column, and they can sort of, if that's thick enough, they can take care of the methane that's being generated deeper down. So that's one mechanism. And another mechanism is there are other microbes that are sequestering carbon into the soil. So they're taking the CO2 and they're putting it in the soil. So you have these different microbial populations, and it just seems to take a while for the community of the carbon dioxide sequesterers to outweigh the methano generators in a flooded soil where you don't have the other group that's aerobic working. It takes decades to thousands of years, depending on which wetland the scientists are measuring, before the switch over to the point where there's enough of a community of the microbes that sequester the carbon to do more of that than the methane generation. It's a really complicated thing, and researchers are just they're really just figuring that out. It's very at the front of the research world right now, and I don't know that they've figured it all out yet. Probably not. So, yeah. Thanks.
I don't think we have time for
Well, just in terms of the ocean, when she said the ocean almost never puts out a lot of methane, in the ocean you've got things that use sulfates for oxygen. If there's not enough oxygen in the soil and it goes anaerobic, you've got to go through the sulfates first, and you'll smell that hydrogen sulfide, and those guys will eat all the guys that are trying to make use oxygen out of carbonate, the methanogens. That's a very hard thing to do. It's hard to make methane. It's a high energy compound. It's much easier to break it down. So if there's any sulfur at all, those wetlands to me are, like on the ocean, are just, very unlikely to do that. So that's the chemistry that you should say. So we had a comment from the audience, I guess.
Yes, one more.
One quick question.
Hi, my name's
You get a
Seth.
free pass because
Seth
of-
at Scan, thanks. This question is for Gillian. Can you tell us how to restore wetlands? And is it possible to restore them in a way where you get the quote-unquote more favorable wetland? Thank you.
I'm trying to think how to do that in a nutshell. Yeah, a lot, a lot of people do restore wetlands can be restored, and in a nutshell, often restoration projects are not as successful as we'd like to see them, and people are looking at that and why that is. And I think actually the ideas about restorative development could be applied. Actually, Jim, Laurie, and I were talking about it. There are some people who are applying these principles of bringing grazers in wetland restoration situations, and that leading to greater biodiversity. So I think the ideas, maybe Jim would talk about that. And yeah.
In Lexington, they take high school kids out and pull up the purple loosestrife for a community project. And that's all fine and good, but after about 2 weeks of this, the high school kids are saying, well, you know, what's the limit here? And the loosestrife always comes back. So there have been people that have taken cattle in, or goats or whatever, and torn up this wetlands to the point where there's a biodiversity that comes back. And you don't have to do it every year, and you don't have to do it for a long time. But it can kind of shift the succession a little bit. So I think that's something that if we look at the research, and there's been a lot of it done, we can see a lot of species come back that has been really absent for a while. So.
And just one quick about how can we favor the carbon sequestration. That's a question that researchers are working on right now. It's the community of wetland scientists, researchers doesn't have all the answers on that yet, but I think there are things out there, such as preserving soil structure. One researcher noticed a 20% better carbon sequestration rate when the construction methods protected the large units of soil rather than allowing them to be compacted by the heavy machinery. So if we can find those types of best management practices, that will help. And then, as Jim said, coastal wetlands are different. They have a sulfur-based chemistry, and they do sequester carbon very, very well. So you can do the coastal restorations, and your biggest enemy there is sea level rise. So we're talking about the freshwater side where it gets a little tricky.
Okay, well, it's lunchtime, and Nancy will lead you to lunch. The waters and the snows will part before her as you head towards the lunchroom. I just want to say that for those of you who got here late or didn't get a chance to register and sign up, we're more than happy to take your pennies. And why don't you come see me and now on your way to lunch, and we can work it out.
Okay. Lunch has been prepared by Chef Carissimo and Chef Esteban Martinez with the culinary arts students. There's a variety of foods. It's going to be delicious. Could the BCC people, local and organic, could BCC people lead our guests from outside of the college over to the G building in the atrium area for lunch? And we'll really reassemble here at 1:15.